Thank you for watching this Hexagon Geospatial e-training module using ERDAS Imagine EasyTrace. In this module, we'll look at digitizing polygon vector features from satellite imagery using the EasyTrace assisted digitizing tools. I'm starting today with a multispectral image loaded in the ERDAS Imagine viewer. This image, a QuickBird 2 image provided by Digital Globe, is displayed using a false color infrared band combination to emphasize the difference between tracks and surrounding sparse vegetation. When performing heads-up feature capture from satellite imagery, it's best to maximize the display parameters so the feature of interest is easily discernible. This will help the operator in manually capturing the feature and also increase the ability of EasyTrace to accurately follow the feature's path or outline. I'll make a few changes to optimize the display. Zooming to 1:1 shows the roads and tracks we're interested in capturing, but not in quite enough detail. I'll navigate to the Home tab and use the Scale drop-down menu in the Extent group to zoom in to 200%. At this scale, I can now see pixel edges. To smooth my image and make the display look nicer, I'll change the resampling method. From the View group on the Multispectral tab, I'll change the resampling method technique from nearest neighbor to bilinear interpolation. Next, I'll need to create a vector layer. I'll use this layer to insert the roads I'm going to capture. I could use an existing road layer, enable editing, and use it to capture my roads. In this example, I'll start with a new layer. I'll create a new shapefile layer by right-clicking in the 2D view and selecting New Vector Layer. I'll give the layer a name such as roads.shp and click OK. In the dialog that opens, I'll select Arc Shape as the shapefile type and again click OK. Note in the Contents pane that there is a new vector layer over the QuickBird layer and that the Vector group of the contextual tabs is now available in the ribbon. In the Style group on the Drawing tab, I'll select a red line color and use the Line Style pull-down to set the line thickness to 2 points. This will set the default styling for any vector I add. I'll adjust the view slightly to better see the roads I want to digitize. I'll use EasyTrace to assist in rapid capture of the curving features we see here. To activate it, I'll click the EasyTrace button on the Insert Geometry group on the Drawing tab. When we want the software to automatically add vertices along a feature, we can turn on the EasyTrace option. I'll turn this on now. There are several feature type options within the EasyTrace tool. Boundary is used to follow edges in the imagery, such as the boundary between a lake and surrounding land. Ribbon is used to trace a feature that has two distinct parallel edges, such as a wide road. Centerline is used to create a single line in the middle of a linear feature. For the roads and tracks in this image, I'll use Centerline. The tracing mode is used while capturing a specific geometry. Rubber band will lay down a continuously updated vector following the feature in the image between the last vertex and the position of the cursor. Discrete shows a straight vector between the last vertex and the cursor, but will only follow the feature when the next vertex location has been clicked. Manual temporarily suspends EasyTrace mode so that the vertices can be manually placed in a classic heads-up digitizing mode. We'll see examples of these in a few minutes. Note that there are keyboard shortcuts between the tracing modes so that you can easily switch while in the middle of capturing a geometry. For example, A, D, Shift can be used to switch between rubber band, discrete, and manual modes. From the Insert Geometry group, I'll select the Polyline tool. The first action required to use EasyTrace is to point the software to a section of the feature which provides a representative cross-sectional template of the feature. This trains the software to recognize the road and assist in the digitizing process. Left-click at one edge of the road and then left-click again at the other edge, across from the first. ERDAS Imagine now has a template to compare to the other locations. I'll place my cursor on the feature to be captured where I want to start the polyline geometry and left-click. I'll then move the cursor further along the feature. Because rubber band tracing mode is selected, a line will be continuously placed where the software thinks the feature is located between the first vertex and the cursor location. This helps to see if I'm trying to jump too far in a single section, or if you captured a poor template. If the rubber band does not stay on the feature, I'll move the cursor to see if it can adjust. I'll place another key vertex further down the road by left-clicking again. The software will fill in more vertices between the two manually entered key vertices. I'll continue down the feature, adding more key vertices until a suitable location is reached to terminate this geometry, such as an intersection. I'll double left-click to terminate the capture and create the geometry. I have more features to capture that have similar spectral properties to the first feature. Because they are spectrally similar, I can turn on the Reuse Template option. With this option active, I will not need to capture a new template before adding a new geometry. I'll turn it off when I need to acquire a new template for EasyTrace to use. I'll use the Polyline tool to insert more geometries. While digitizing, note that EasyTrace cannot negotiate sharp bends in linear features, so add a manual key vertex at the apex of any sharp turns. Also note that if you encounter a section of the feature that is spectrally different to the template, EasyTrace may not be able to follow the feature in that section. Add a key vertex just before the problematic section, swap to manual tracing mode, which can be done by pressing Shift on the keyboard, and manually digitize vertices to jump the gap. Then, turn the rubber band mode back on again using the A key. If I'm digitizing and reach the edge of the current display extent while capturing a geometry, I can hold down the middle mouse button to drag the data to a new location without needing to stop capturing the current geometry. EasyTrace may not work in all circumstances, but as we've seen in this module, it can often significantly increase the efficiency of capturing complex geometries, which would require considerable user input if captured completely by traditional manual digitizing methods. Thank you for watching this Hexagon Geospatial e-training module. For more e-training, please visit hexagongeospatial.com/etraining.